Hello everyone. Today we're looking at the paper Multitask Prompted Training Enables Zero-Shot Task Generalization by a large number of authors from different institutions, as you can see here. This paper focuses on the problem of zero-shot generalization for natural language processing models. The goal is to be able to build a general-purpose model that can solve new tasks unseen during the training process. The authors propose a new model called T0 that focuses on the problem of explicit multitask learning. By explicit multitask learning, what we mean here is that the model is trained to solve explicitly multiple tasks at the same time using a common format. For example, summarization and sentiment analysis and question answering. Each task is represented with a carefully defined prompt that specifies what the goal of the task is and what is the required output. For example, for summarization, the model might be presented with an article and might be asked, how would you rephrase that in a few words? For sentiment analysis, given a review, the model might be asked to say on a scale of 1 to 5, I would give this A. So conceptually, this is somewhat similar to how large-scale language models do prompt learning, for example, GPT-3, which you are probably familiar with. However, instead of a decoder-based language model, here the authors focus on using a encoder-decoder architecture based on the T5 model. So given this prompt, the decoder of the model is supposed to output the summary or the sentiment or the answer to a question or any other task that the model is trained on. During the training process, the authors train on several tasks, as I said. To be precise, quite a few of them. Actually, multiple choice question answering, extractive QA, closed book QA, sentiment analysis, topic classification, structure to text, summarization, and paraphrase identification. All of those are represented using the carefully defined prompt template format, which is described in the paper and supposed to give a common format that the model can generalize. It can also generalize potentially to unseen tasks as well. And once the model is trained on these tasks, it is then evaluated on some held out tasks which are not used during the training, namely sentence completion, natural language inference, co-reference resolution, and word sense disambiguation. And the model is supposed to solve those tasks in a zero-shot setting, so without having seen any NLI examples, for instance. So this is quite challenging, of course, and I encourage you to also take a look at the templating language that the authors propose. It seems to be quite good, quite interesting. How to represent all of those tasks the same in a common framework. It's not easy. So after training and evaluation, we can take a look at some results. And the main focus here is on comparing the performance on few-shot tasks, comparing the T0 model with GPT-3 model in different configurations. And one of the main takeaways of the paper is that the T0 model with 11 billion parameters is able to outperform various GPT-3 configurations, even the largest GPT-3 configuration here, which contains 175 billion parameters on 9 out of 11 evaluation datasets covering the 4 tasks. T0 is able to outperform, which is a nice result. Even though here, arguably, it's kind of a slightly different setting in a way, because the GPT-3 model, of course, is just trained on large amounts of text without any structure in it. And it maybe has seen some of the examples that are part of the training set used to train T0. For example, some of the articles used in the summarization datasets might be part of the large dataset used to train GPT-3. However, GPT-3 hasn't seen any structure of any prompts and any examples of how to solve tasks. So it's like not an explicit method, whereas T0 is an explicit method for learning this multiple tasks and to learning to generalize to new tasks. So this is the interesting comparison. Of course, it's arguable whether this is a fair comparison in the sense of should we only compare models trained on explicit multitask learning or is it fair to also compare with GPT-3 here? It's a little bit questionable in my opinion, but it seems that explicit multitask learning is outperforming implicit or multitask learning. And another interesting takeaway of the paper is that training on more tasks, more explicit tasks, helps with few-shot performance. So if you train not only on summarization and question answering, for example, but summarization and question answering and sentiment analysis, let's say, it is highly likely that then your model, your T0 model, is going to perform better on natural language inference, not part during the training process, as an illustrative examples here. So it seems to be beneficial to train on as many tasks as possible to have a general purpose model, which then can work on these novel tasks. So that is what I wanted to cover for today's paper. Please like and subscribe, and I'll talk to you in the next one.